Alright guys, welcome back to the another video. In last video I have showed you how to download your train and test dataset satellite imagery using Google Earth Engine, and also I have clipped my water bodies which is the shapefile representing water surface in the land. So in this video I'm going to create the image tiles based on this my vector and the raster dataset. So if you want to know how, then watch this video till the end. Let's get started. All right, for me all the code from this particular course is available uh, in this folder. So if I type cmd, and it will open the command prompt, and since I'm going to use the Visual Studio Code Editor as my code editing software, that's why I'll write code dot, and then it will launch the Visual Studio Code Editor. And if you don't know how to if you don't have the Visual Studio Code Editor, make sure you install the software, or you can do the same process in Jupyter Notebook as well. So for generating marks and tiling, I wrote the generate tiles.ipynb file, and of course you can run the notebooks in Jupyter Notebook. Run the notebooks in the Visual Studio Code Editor. So here I want to open my terminal as well. So in the terminal, so right now the first step is to create the virtual environment and then install the dependencies. So if you haven't installed the virtual environment, then you can install it by conda create -n and then your virtual environment name, which is for me it's deep learning, and then you can define the Python version, Python equal to 3.10 and conda, anaconda, so that your virtual environment will be installed. And after that, since I already installed the virtual environment, that's why I don't need to run that code. And after that, you can activate this by conda activate your virtual environment name, which is deep learning for me. And after you after you activate the virtual environment, so your virtual environment name will be available over here. And then we have to install the dependencies. The first dependency is I am going to use the GeoTile package. So over here, if I search for GeoTile GitHub, and you will launch in this GitHub repository. And if you haven't started, so please make sure you start this repo. It means a lot to me. And here I'm going to use this package, and then if you struggle with the installation or something, you can definitely check the documentation. So okay, I'll simply explain what are the things we need, and based on that you will get overall idea about this GeoTile package. So for the installation, you can jump to the install directory, and then here is the installation command conda install -c conda fork GeoTile. And of course, if you are not able to install this with this command, then make sure you install the GDAL, numpy, GeoPandas and rastrio before installing this package. And after that, you can simply install with the pip install GeoTile. So I use the conda command over here. So I already installed my package, so I don't need to again install the package. So yeah, so now my my virtual environment is activated, and also you need to select your virtual environment by select kernel, and then maybe deep learning. Also, the other thing is you need to install the Jupyter extension and the Python extension in order to run the activate your virtual environment, and then simply run your ipynb file in the Visual Studio Code Editor. So I'm doing it here. So yeah, after that your virtual environment will be available here, and then you can select that kernel. All right, so my extension are successfully installed. So if you are like still struggling with how to like install that extension, so you can simply click on this button and then search for the Jupyter and install it with the install button over here. And then after that, so search for the Python extension and then simply install it by clicking link over here. All right, so after that, let me move back to my code. So here I need to select my kernel. So my kernel will be the deep learning over here. So you can see deep learning package. So after that, so you can like write your own code and then run it like in the Jupyter notebook. So the first thing is I need to import GeoTile package. From GeoTile, import GeoTile and then hit run. And if it runs successfully, that means we successfully install our GeoTile package. All right, so after importing this GeoTile package, so first of all I want to like list out the train x, train y, test x and test y variable which are over here. So if I showed you, all the my data set is inside data directory and into indl and then xtrain. So this dot dot slash dot dot represent its two folder up to the actual code. So all right, so run it. And after that, so first of all I would like to like generate the tiles from train data set and then the generate the max from train data set, and I'll show you how to generate the same thing with the test data set. Okay, so for the train data set, so I can write gt.train and then I can initialize the GeoTile package with the path of the raster. So path and then train x, which is the raster. And then of course if you want to see some metadata, so you can write gt_train.meta and it will initialize the GeoTile package with this train x raster. So here it's downloaded previously. We have 4-band RGB and NIR and the data type is fluid 32-bit. And these are the other bunch of informations which I think you might not be interested with. Okay, so after that, so the generating the tiles from GeoTile package is quite easy. So there is the option to generate tiles and then you just need to like provide the path to the output folder, and by default your train I mean the tiles will be 256 by 256 width and height with the 50% overlapping, but you can definitely like alter these things. And also there are other things like prefix or suffix. You can like generate the raster based on like your required prefix and suffix command. Okay, so for the output folder, so I also want to like store it inside data and then into indl, and then maybe I'll write the train x tiles or just the train x tiles. Okay, train x tiles. And if I hit run, so it will automatically like add the folder called train x tiles, and then my tiles name will be like this. But one thing I just noticed is the naming is quite pretty little bit weird. So tile 0 0, tile 0 to 1 to 8, tile 0 to 56. So if you don't like this kind of naming convention, so you can simply provide like prefix or suffix code and then write your like whatever you need. Okay, so I'll write prefix will be train and then simply underscore, and let me delete this folder first and then rerun it again. So after that your tile name will be train 0, train 1, train 2 and then up to the number of tiles you have. Okay, so for generating the like y value, which is the max value, of course if I show you over here, so my train x vector is the like say file representing my study area, right? So in order to like generate the like max from this shape file, you need to rasterize it first, and then after that you can like get the tiles from that particular raster. Okay, so for that, so maybe I can like toggle it back. Okay, so for that, so you need to like rasterize it first, rasterization, and then you need to provide the input to the vector file, which is uh, it's it should be like path train y value, which is the like shape file, and then path to the output file. So output, I want to save it inside data directory into indl, and then maybe y uh, train.tif. Okay, so that's also simply hit run. After that, you will get the file called ytrain.tif, and if I like load it in the QGIS, so you will see the raster max with the exactly same like water bodies. So okay, so if I okay, so all the like zero values will be like covered with the black spot, which is zero value, and all the like shape file will be covered with the one value. So if you would like to like see the actual value from this raster, so this white pixel are value of 1, and then the black are with the value of 0, which is quite obvious. Okay, so yeah, so in this way you generated the raster with the like bigger chunk. But yeah, in order to like generate the tiles from that raster, so you need to again initialize your uh, like GeoTile package train y, and this time it will be like GeoTile, and then path to the raster, so which is data into indl, and then y train.tif, and then gt train y dot generate tiles, and then make sure you generated the tile with the like similar it's similar to the previous one, because each tile should represent the like corresponding max. So that's why so you should not like change the tile x and tile y value, which is the width and height of the tiles. So it should be like match with the our like x x tiles. So that's why I'm simply like providing the path to the output folder, and then into in the dl, and then maybe this time uh, train y tiles, and then prefix will be train. Okay, so if I hit run, so it should generate the tiles for y values as well. So if you want to see how it looks like in QGIS, so maybe I can select the random tiles. Let me select the 30. Okay, just hit close and zoom to here. Okay, so this is my 30 tile, and then the corresponding y value, so 30, sorry, it should be in QGIS. Okay, so this is the like water body, so okay, so it shows that this is the water body, but I'm not sure whether my like tiles are correctly generated or not. So you can manually check with the like visualizer. So maybe I can check with the first tiles. Okay, so in first tile I don't have any like one value, which is the like water body, so I can remove it. Okay, so anyway, so in this way you can simply generate the like tiles for the train dataset, for the test dataset as well. So you can like do the like similar things as I done in the previous section. So simply for the y test gt test will be like GeoTile, and then path uh, test x, and then gt test dot generate tiles, and then it should generate the tiles inside data directory into indl, and then test x tiles, and then similarly I can provide the prefix as well. Prefix will be test, and then I can like rasterize my test file, rasterization gt dot rasterization, and then path test y, path test y, and then I can put the like directory where I want to like save the file into dl, and then y test.tif, and after that I can simply like initialize the gt test y with GeoTile, and then path to that raster data dl, and then y test.tif, which is same path as the previous one, and after that gt test y dot generate tiles, and then it should be like data and int to in dl, and then test y tiles, and then prefix will be test. Okay, so if I run this code, it should generate the like two extra folders, which is okay, test x tiles, which is already generated over here. So these are the like test tiles, and then it should also generate the test y tiles folder, which is over here. So yeah, so in this way you can simply generate the tiles. Of course, if you want to check these tiles manually, you can like simply go to the QGIS and check it, or you can also check it using the matplotlib package. One thing I don't like about these tiles is there are lots of files. So there are multiple files, so it's a little bit hard to handle. So that's why in the GeoTile package, there is a function to save these tiles as a numpy array. So in order to do that, so I'm simply pasting some code over here. Control T, and I'll show you from where I got this code. So in the GeoTile package, there is like advanced use case in deep learning guideline. So using this guideline, so the first thing is generating max from the vector data. So I already showed you how to generate the whole study area max file, and after that generate the tiles from both imagery and max. So here actually, so instead of generating our tiles as TIFF files, so you can pass save tiles equal to false option, which will only store your tiles inside that GeoTile package internally, and after that you can like do the preprocessing if you want, and then save the tile as numpy array. So yeah, so in this way you can do that. So in order to like do that, so simply write the like gt train dot generate tile, and then this time I'm passing only one parameter, which is shape tiles equal to false. And then similarly for the GT-train y dot generate tiles, so it's also false. And after that I can do the preprocessing, convert none to 0 or normalize the tile. Okay, maybe like before doing these two steps, so I want to show you one thing. So if I run this cell and if I print out the like minimum and maximum value of GT train variable, so it will be like different. So in the GeoTile package, actually if you pass like save tiles equal to false, then it will be saved internally inside the tile data variable. And then if you try to look it at save, so by default there will be like 442 like tiles, and then the tile x and y dimension is 256 by 256, and then the image there are 4 bands, right? So if I say like minimum and then gt train dot tile data dot maximum, so it will be none, right? So that's why we need this function to convert this none value to the 0 value. So if I run it again, and then if I show you again the minimum and maximum value, this time you will see the minimum and maximum value is somewhere between 0 to 1, but it's not exactly like reached to 1. So let's wait few seconds. Okay, so my like train dataset variable like varies from 0 to 0 0.5 to 66 value. So in order to like simply like make it between 0 to 1, which is the major step in deep learning, so the data normalization we call it. So in order to like normalize your data, so you need to like run this function normalize tiles, and if you run it, so now your value will be like between 0 and 1. All right, so the final step is to like save it as the numpy array. So let me copy this code and then paste it over here, uncomment this, and then simply hit run. So if you run this, so you will simply save the x train and y train dataset in the numpy format. So in this way it will be like very easier to handle your dataset. So you can see x train npy and y train npy files in your folder, and similarly you can do the same thing for the test dataset. So I showed you for the train, so it's up to you whether you want that dataset right now or not. So yeah, so it's really easier to like save your dataset as a like a numpy array. So yeah, so I hope you enjoyed this video. If you enjoyed it, hit the like button and subscribe to my channel. Thank you for watching.